Okay, give the title on. You need your name, date, and period. Today is the 24th. Okay. Our essential question for today is, so let's put what are the special cases polynomials? And what are the tricks? Because these are going to have tricks with them that will make the process shorter. Special cases of polynomials, and what are the tricks? Go ahead and draw your column now. Yeah. Go ahead and there we go. Now I can fix it. You guys know I always go back up after I draw the column. What are the special cases when multiplying polynomials, and what are the tricks? Okay, Tristan S., looks like we need to give you a new seat. Well, unfortunately, your neighbor can't handle sitting by you because you are just so fun to sit by. So, right here in the front is an open seat. Please take all your stuff and that'll be your new seat.
I come over right here?
Nope. Thank you, Tristan, for moving so quickly. Okay, so the first type of special case we're going to do today is called perfect square trinomials, factoring perfect. So write that in, please. Factoring perfect square trinomials. Ooh, gonna barely fit. Ooh, S doesn't fit. There we go. Factoring perfect square trinomials. This mic, see if it's not dying. Factoring perfect square trinomials. Okay, so we know what a trinomial is. Show me with your fingers how many terms a trinomial has. How many terms does a trinomial have? Thanks for showing me with your fingers. Good. 3, right? 3 terms. But what's a perfect square? You should have heard perfect square before. In fact, I'm pretty confident you've all heard it before. If you remember it, that's another thing. So, perfect square. What's a perfect square, Phoenix?
Where if you square something, it's perfect. It's not like a decimal, it's a whole number.
Okay. Really close, but when you take the square, it's not just square, it's a square root. Good. Okay, I'm going to draw a picture that I'll be erasing so you don't actually have to draw this. Okay, so let's just talk about it really quick. Perfect square. Well, a square looks like this, does it not? Pretty. Sorry. There you go. Does that make you feel better? Okay. Okay, so we know a characteristic of squares. Alyssa, what do we know about squares? They have 4 sides, and what do we know about those sides? Like this side and this side. This is for Alyssa. If this side is 7 feet, Alyssa, what do we know about this side? 7 feet as well, right? Because they're all equal. So the area is length times width. Okay, so Lexi, we go 7 times 7 for the length and width, right? So the area of the square, what's 7 times 7? Lexi, I said. Thank you. Lexi? 49. Now, what would the unit be, Lexi? If we do feet times feet. Feet to the second power, feet squared. Okay, so that means that 49 is a perfect square. It forms a square. Whoa, it is perfect. Because 7 times 7. So he was saying, once we got the word square root, if we take the square root of 49, it comes out perfectly. We don't get a decimal. Okay, square root of 49 is positive 7. It could also be negative 7, but today we're looking at positives. Okay, so 7 times 7 is 49. So therefore, 49 is a perfect square. Can you think of another number that's perfect square? Raise your hand if you can think of another number that when we take the square root of it, it comes out perfectly. What else is a perfect square? Gerardo? Okay, so what's 3 times 3 then? No, what number do you get? What's the product? Not 6. 3 times 3. 9. So 9 is a perfect square because the square root of it is 3 times 3. So our sides of the square are 3 and 3. Okay, Alex? 4, because square root of 4 is 2. 2 times 2. Annabelle? 81, because the square root of 81 is 9 times 9. Front row, you're staring off in space like you've never heard this before. Do you know the square root of 81? Front row here, what's the square root of 100? No, half of 100 is 50. But what times itself is 100? 1 times 1 is 100? Wow, I'd be rich if I had a dollar bill and another dollar bill. I'd be rich. Okay, so it's not 1 times 1, but Brayden? It has to be the number times itself. Like 2 times 2 is 4, 3 times 3 is 9. So there we go, 10 times 10. Does that make sense? Has to be the same number repeated. Hakeem? 25, because 5 times 5, right? So I think we get the idea. So we have, if we go in order, we have 1 is perfect square because 1 times 1. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and that's as high as I can go. Someone last period said 256, which I think was the square root of 16. Or the square root is 16. But, okay, after 12, I even get a little confused. All right, so we're looking for perfect squares. Now, perfect squares don't have to be a number. It could also be a variable. So, our first example is, let's see, x squared plus 8x plus 16. Example 1. Again, x squared plus 8x plus 16. Now we're going to skip about 2 lines. Okay, skip 2 lines and we're going to write the steps for how to recognize if it is a perfect square trinomial. You can solve this using the box method. It just takes longer. So if you recognize, oh, this is one of those special ones, you can solve it faster because we have a trick. So there's 2 methods you can do it. If you just always want to do the box method, that's cool. Or you can realize, oh, there's a faster way to do it if I can remember this trick. Okay, so to recognize first that it qualifies, so skip about 2 lines and put steps to recognize perfect square trinomials. Ooh, I'm gonna fit. Okay. Steps to recognize perfect square trinomials. The first qualification is the first and the third term have to both be perfect squares. So the first and third terms must both be perfect squares. First and the third terms must both be perfect squares. Okay, so let's see here. I think we've talked about 16. Is 16 a perfect square? Why, Tristan S? Great, because 4 times 4. 4 times 4, which is 4 squared, right? So I'm going to put a little check mark. That qualifies so far. Now, here's a tricky one. Is x squared a perfect square?
Yeah.
Because, why? But how do we get the x, though? What times itself is x squared? X times, there you go. So x squared is perfect because x times x, it works. Okay, so it meets the first qualification. The second qualification that it must meet is that once you look at the factors of the first and the third terms, this is kind of complicated, so I'm just going to read it first and then we'll write it down. The middle term is twice the product of one factor. That's the first half. The middle term, or the second term, is twice the product. Okay, what does twice mean? 2, what does product mean? Multiplication, so we're multiplying by 2. Twice the product of one factor from the first term. Of one factor from the first term. I'm just going to put first term because I think it helps your eye see it better. And one factor from the last term. And one factor from the last term. I'll read it again and move out of the way for those on this side of the room. Okay, so the second term is twice the product of one factor from the first term and one factor from the last term. Okay, so we have to find the products, or excuse me, the factors. So let's look at factors of x squared. What are the factors of x squared? And we talked about factors at the beginning of class. They have to be smaller than or equal to the term. They have to divide evenly. Okay, Tristan, can you think of a factor? Tristan W. What divides into every number? Evenly. Not necessarily. 1. So one of the factors of x squared is 1. There's another factor of x squared. What divides into x squared besides 1? Besides 1. Brayden, what do you think? I'll give you a hint. It's not a number. It's a variable. X. Good. And x squared goes into itself, right? Which is a little funny to write, but x squared. Okay? And then when you do factors of 16, once again, the smallest one, we always start with, don't forget that there's that 1. What's the next smallest factor of 16? I hear it. 2. And then you said 4. Then what's the next factor? 8, and then 16 itself. So we're looking at which factor times 2. This is really nice when this is a 1, because we take the 1 and multiply by one of the factors over here on the right times by 2. So which factor over here on the right times by 2 equals 8? Not 1 times 8, it has to be times by 2. 2 times 4. And if we times it by that 1, then it's still 8. So it's really nice that we have a 1 out here. So it's still 8. Okay? So 4 times 2, which means that our factors, we have x plus 4, but if this is a square, are the sides of the square exactly the same length? Yes. So if we have x plus 4 and x plus 4, how do you write the area? X plus 4 squared. Good. Oops, it's not writing. There we go. Now it's writing. Okay, so that's our answer for those are the perfect square trinomial factors. X plus 4 squared, because there's 2 of them. Okay, right now it looks like a long process, but we don't have to always write these steps. So we're going to try it again, and you'll see it's very quick compared to doing the whole box method. Okay? Example 2. Let's do x squared plus 6x plus 9. X squared plus 6x plus 9. X squared plus 6x plus 9. Okay, the first thing we need to find are the end terms perfect squares. Is x squared a perfect square? Gerardo, are you writing?
Yep.
X squared is a perfect square because x times x, right? That's the same as the last problem. Now we have to see, is 9 a perfect square? Alejandra, is 9 a perfect square? Or, I'm sorry, it's Evelyn. Alejandra's your neighbor and she's not here. Evelyn, is 9 a perfect square? Okay, what times itself is 9? 3 times 3, right? So we write 9 is a perfect square because 3 times 3. So let's look at the factors. What are the factors of each of these? Okay, also what are the factors of x squared?
X, y, x squared.
Good. Okay. So that's the same as the last problem. What are the factors of 9? Brianna? 3 and good. So that's all of them. So we look and find which factor, and we always times by 1, so really we only have to do this list on the left. Really focus on the list on the right. Which one times by 2 equals 6? 3. See that? 3 times 2 equals our middle coefficient, 6. So now we can write our perfect square. Now we can write the perfect square. Okay, Susan, what goes in our answer for the perfect square? X. Perfect. And then squared, like that. Okay, x plus 3 squared. Is this making sense? Great, let's try another one. I'm going to have you do the whole thing by yourself. Example 3. X squared minus 14x plus 49. Okay, x squared minus 14x plus 49. I want you to try to factor it using this trick of a perfect square trinomial. Find a neighbor that did something. This one actually has a little bit of a problem at the end, doesn't it? Did you notice? It's the negative 14 that causes a little bit of a problem, but it's really not that hard if you think about it. Okay, Junior, can you be in your seat, please? Okay. Well, I paired him up with Susanna earlier. Okay, so is x squared perfect square? Yeah, we've seen that one multiple times now. Okay, some of us are having a hard time with 49. What times what is 49 for... Okay, so let's go with the perfect square first. For the square root of 49 is 7 times 7. Okay, now if we list the factors... Okay, we always have 1 in itself, 49. And then what else is in the middle? What other factors? 7, any other factors? No. So when this factor has a 1 and there's nothing in front of it, it makes it really nice because we just only have to focus on this right side. Okay, what times 2 equals negative 14? Negative 7, because can factors be negative? Yeah, so actually all of these factors are plus and minus. So that's how we can come up with a negative 7. So that gives us our binomial x minus 7 squared. Okay?
Now, what would happen if, say, the 49 was negative?
That wouldn't be one of these problems, and you just have to do the box method. But you know, see that what he just asked said, what would happen if the 49 was negative? Guess what level question that is? 3. So that could be a column question. That was a great question. So when you have these questions along the way, you can fill them in the column. You can write that one right now, and as long as you can explain it. because in the summary you have to answer it. And if this was a negative, it wouldn't work because it wouldn't be a perfect square. It'd be something else we'll learn later on this year. Okay, so you just have to go back to the box method. Okay, I'm going to see, we're going to do one of these that are very similar, but one extra level of difficulty. It is 4n squared minus 12n plus 9. 4n squared minus 12n plus 9. Okay. Raise your hand if you notice what's different about this than the last three. Oh, good. Hands are already up. What's different about this example than the last three we just did? Great. Also, what do you notice different?
Instead of first term being x squared, we actually have a coefficient and a variable.
Yeah, so it's not an x anymore, it's an n, and then there's a number, a coefficient with the n squared, right? So we have a 4, which makes it, we don't necessarily have the pretty 1 in front anymore. So, but we do the same thing, because is 4n squared a perfect square?
Yes.
Because what's the square root of 4? 2, and the square root of n squared is? N. So, let's see, 4n squared equals 2n times 2n. So that works, because those are equal to each other. And we know 9 is a perfect square because 3 times 3. So same process, we just have a number in front of the 2. So now let's look at the factors. Okay, and really with the factors on the left, we're only looking at the coefficients. So what's the factors of 4? 1, 2, and 4. And what's the factors of 9? Okay, 1, 3, and 9. Great. Any questions of what we've done so far? Okay, now here comes, since we have this extra coefficient in front, it might not necessarily be the 1, it could be, but we actually have to look at these factors. 1 times one of these, 1, 3, or 9 times 2, does that equal negative 12? 1 times 1 times 2, does that equal negative 12? 1 times 3 times 2, does that equal negative 12? 1 times 9 times 2, does that equal negative 12? No, so unfortunately it's not the 1. So let's look at another one. 2 times 1 times 2, does that equal negative 12? 2 times 3 times 2, does that equal negative 12? It's close. What is it? Times 2 though, because remember the step up here? The second term is twice the product of the first and the third's factors. So we have to times by 2. How do we get a negative out of all this? Because they're all plus and minus. Okay, so if we're multiplying by 2, what number times 2 would equal negative 12? Well, negative 6. So, which one of these with which one of these makes negative 6? 2 and negative 3 doubled would be negative 12. So we found it. Now our answer looks slightly different because this time our n has a number with it. There's going to be 2 n's minus 3, and then what? Squared. Dun, dun, dun. There we go. Yes.
So if there's a coefficient on the first term, the answer will have the factor on the...
There will be a coefficient with the variable, yes. Yes. Okay, there's one more rule which isn't as complicated as this rule. So this next rule will be really fast. It is called difference of 2 squares. Difference of 2 squares. So if you notice, we're talking about squares a lot. So we're looking at perfect squares. I hope you've listened today and now understand what a perfect square is. Difference of 2 squares. So I believe we're on example 5. Okay, difference. Who can tell me what the word difference means?
Divide.
It does not mean divide. Asa? The answer, not just subtraction of anything, it's the answer. That's the part of subtraction, it's the answer, so thank you. The answer to subtraction. So, let's look at the first one, v squared minus 100. Notice it's a binomial. Okay, if you don't realize that this is a special case on your assignment, you can still apply the box method if you can fill in the middle value. Okay, this is v squared. Minus 100 is v to the 0 power. How many v's to the first power are there? No. There's 0. It's not there. Is there just a regular v? No, so that's 0v. So you can still do the box method as long as you realize it's 0v. So in the box method, we look for two numbers that multiply to negative 100 but add to 0. Okay? So let's look at the trick here. Is this a perfect square, v squared? Because v squared equals v times v. And I think we talked about this one earlier, Braden. What's the square root of 100? Good job. Okay, so we ignore the minus sign, right? And so we know that 100 equals 10 times 10, so it's a perfect square. So, but how does 10 and 10 add to 0? How does 10 and 10 add to 0? How does 10 and 10 add to 0? I appreciate you 4 boys, but I call on you a lot. So let's get a couple more hands that don't normally pop up. How does 10 plus 10 add to 0? 10 and 10. How does that add to 0? Blanca, do you know how 10 and 10 adds to 0? Okay, so how many of them would have the subtraction sign? Is it going to be negative 10 minus 10? So they both don't get a negative sign. How many gets a negative sign? One has to be negative and the other one has to be positive. So our answer looks like this. V plus 10, V minus 10. You see? One is positive, one is negative. Pretty much.
Oh, you got that?
I did. Okay, let's have you guys try the very last example and we'll write down your homework. S squared minus 16. S squared minus 16. Now, if you don't realize right off that this has a trick that will be faster, then you have to remember that what's the middle term going to be? 0s. So you can still do the box method. Okay, is s squared a perfect square? Because s times s, those are s's, not 5s. Okay, now Lexi, what about 16? Is 16 a perfect square?
Yes.
Because what times itself is 16? 4 times 4. Yep, because the square root of 16 is 4. So, given that, and they both have to add to 0, you have to add to 0. Jessica, what would our answer be? Just like the last one where we got the factors were 10 and 10 and they had to add to 0, so we wrote v plus 10 and v minus 10. Not 16. Look at the factors. 4, there you go. So one is s plus 4 and the other one, Jessica, would be? Great. S minus 4. Okay, so your homework today is 2. We've done 2 sections. Don't start cleaning up. Don't start cleaning up. We've done 2 sections. So Jared has already found one higher level thinking question he can write on the side. You need a level 2 or a level 3 question for each section. So I'm asking for 2 questions on the side. One for the top section where we did, oh goodness, what were they called? Yeah, perfect square trinomials. And one for this new section called difference of 2 squares. With that, your assignment, which has extra credit on it, another way you can get extra credit is having your parents come see me at parent-teacher conference if they haven't already. And the extra credit is right here. So this is your homework on the board. Please write it down. And we'll be checking both this off and page 680 from last time in class on Thursday. So you didn't do 680 through 682 that I assigned last time. You have 2 more days to get it done.